Well, welcome everybody. This is the third or fourth webinar now in our new webinar series for the Computational Social Science Society of the Americas. Thank you for joining us. It is just after 10 a.m. Eastern, that's 8 Mountain, and 7 Pacific. And joining us today is Tom Pike. He's a colonel in the Army and currently teaching at the National Intelligence University. And he recently completed a PhD in Computational Social Science at George Mason University. Given what you're going to be talking about today, my guess is Rob was your advisor?
That is correct.
Okay. So Rob Axtell was his advisor, and he'll be talking to us today about building some MESA packages to make agent-based models more accessible for policy analysis and for policymakers. And without further ado, Tom, please take it away.
All right. Thank you, Matt, for this great opportunity. I do have to start with a standard disclaimer that what I'm about to say does not represent the views of the U.S. government, the United States Army, or the Director of National Intelligence, or the National Intelligence University. So mandatory disclaimer there, but let's just jump right into it. So the idea is, really the concept, right, of how can we get agent-based models more to the hands of policymakers. So as Rob Axtell would say, we can use them as virtual laboratories to ideally make better decisions faster. And so I would contend that the situation is right now, if you look at things like OpenABM, or you look at NetLogo as two pretty large libraries of models out there, that individuals and teams are building these ABMs from scratch. And although they might be using libraries like Mason or NetLogo or Repast, it's still kind of a forest of standalone models. All right, but inside these models are a lot of the critical building blocks I'll discuss a little bit later, where that could be used in other models and would also, I'll contend, would help deal with part of the reproducibility crisis, where people could take those building blocks and put them in other models, right? And also, if we get those building blocks removed from these kind of individual models, then other people can crowdsource them and constantly improve upon them. All right, so really situations, the current repositories, or at least all the ones I've seen so far, right, store whole models and not pieces of models that can be recombined, or those pieces advanced to kind of move different parts of the agent-based model dynamic forward. All right. This slide, so the goal, and this isn't necessarily a new idea, right? So being used, is pretty pervasive across computer science, is to create repositories of ABM algorithms which can integrate with the common frameworks, right? So ABMs are probably like an order of magnitude harder than other things, because you first have to have that framework of data collection, agent sequencing, and all those dynamics that you find in Repast and MESA and Mason. Right, and then on top of that, then you have to have building blocks, right? But the idea is already pretty pervasive. So I put up scikit-learn and TensorFlow, which is Python's machine learning library, as well as one of Python's deep learning modules. And even these are kind of getting less and less abstract, as on top of TensorFlow, you now have Keras and other things that make building a object detection with a deep learning module even easier, where it just takes fewer lines of code, and just your challenge is really the data, right? And from these libraries, you get crowdsourced improvement. You kind of get this mix of corporate sponsorship and individuals and organizations all kind of focusing on the same code to make it better, right? And then you can kind of see this progress where they're even making it easier and easier for people doing data science to leverage these tools with some pretty powerful outcomes, just based off kind of the prevalence of data science in the discussions today. All right. So it's a theoretical justification for this. So you see the picture here on the left from Holland's book, Hidden Order, where it's complex systems. You have building blocks, all right, that you can put together and recombine, and that's. You can also look at Herbert Simon and his parable of the two watchmakers, where having these building blocks is critical to trying new things and being able to advance faster. If you try to build the same thing over and over again from scratch, it just takes a long time, and you're not able to make progress. But if you're able to pull apart and use building blocks, then you're able to progress much faster. But I'd also contend this will help us, as Volker, Grimm, and all say in their paper, Pattern-Oriented Modeling, some insights from ecologists, is that this will, if the ideas, analytic equations that are kind of typical way for science, like E equals MC squared, are not necessarily representative of complex adaptive systems, and we have to find these simple generative mechanisms, right? So I got a picture of the Koch curve here as a fractal that has a simple generative mechanism that as the orders increases in complexity. So that same idea where if we have these building blocks, maybe we could realize, identify some simple generative mechanisms kind of ubiquitous in various domains of complex systems, and start to use that insight to better understand complex systems in general, and kind of move that theory forward. All right, so these become the justifications for why we should do this, and it's not just kind of like an idea based off machine learning. I would contend that this idea is strongly supported by complex, just by the theory of complex systems. All right. But there are going to be some challenges. So on the left here, you have kind of like the major libraries. There's actually more than this, but these are the kind of main ones I've been exposed to over the years. All right. And then, so how can you have extensions to these, if you will, that allow people to put in, as examples of what these building blocks might look like, is routing behaviors, how you pick your route going from place to place, trading behaviors, if you're using like economics models, a lot of agent-based models are used for flow control, for both traffic and crowds in various places. So those kind of those flocking and herd models are just crowd movement models, having those building blocks available to people so they can put that into various models, or even, if you say agent-based models for cell behavior, so having those very well-known kind of dynamics available to the entire users. Right? And I won't belabor this point too much, right? But just you have building blocks of behaviors, building blocks where you have landscape behaviors that people could pull in, or even building blocks where you're able to pull in specific types of agents with specific features, as well as potentially specific methods that serve as behaviors within the agent-based model. The challenges you're going to have with this, though, as you look at that, is that at least from the experiences I've had building my own models, as well as working with other people, it is no small feat just to get a model working the way you want it to, get it verified and get it validated. And it is by no means, you could draw out your blueprint and then build the model. Right? You think you have your idea, and then by the end, your model doesn't necessarily look or is not nearly as neat as you want it to be. So there is some significant cost to, you've built a model, it's doing what you want. Now you have to go back, right, kind of reshape how it's formed so you can pull out critical behaviors or critical elements of that model that you think that a model or thing could be used as a building block. All right, so that's the first challenge. There is an additional cost to this. All right. In addition, you also have multiple parts adapting at once, right? So, particularly like repass MESA and MESA, they're all, just like Python, are making forward progress and trying to come up with improvabilities, fix bugs, and stuff like that, which when you combine that with a bunch of different building blocks potentially being run by, vastly different people all over the world, it's going to also be a challenge to make sure that they maintain their compatibility. So there have to be some pretty, there's got to be some structures and rules in place, so old building blocks don't get broken if the framework is updated and things of that nature. In addition, I've also seen there's a typical reluctance to kind of share building blocks, which is, I'd say, human nature. I realize it's just kind of embarrassment where you write something up. Typical papers go through a lot of vetting and proofreading, not so much with code. And so people, are often reluctant to share their code just because they don't think it's good enough. My impression is now that nobody ever thinks their code's good enough. And this seems to be a cultural change where everybody just kind of accepts that, and so people are more willing to share their code and have in this kind of open source environment. So that's kind of the rough idea, but there are I would contend some significant challenges in overcoming both culturally and realizing that there's that additional cost to taking code that's been written and turning it into a building block that somebody else could use. And then maintaining that code base as the whole ecosystem kind of evolves together. With these ideas in mind, I work primarily in a Python library, MESA, which was started by Jackie Kazel and David Massad, both out of George Mason as well. And so that's now going to focus the rest of that, right? So that's the concept. How can we get these building blocks up there? What will a repository look like? And this is at the very nascent stages. So, really my purpose here is to try and spread, hey, we got this idea. And if anybody out there comes up with a building block or wants to help build out some of this infrastructure, it's a very open source project. And the more help we can get, the better. But the idea from Jackie and David is to keep really what they call core MESA, keep it slim and lightweight, right? So it doesn't require a lot of extra extensions to keep it running. It doesn't have a lot of code behind it, so it can be installed without a lot of overhead. All right, and they see really any kind of extension from core MESA, and really you could kind of put them in two bins, right? So first, there's you extend core MESA to something like GeoMesa. Where in this case you can import shape values and things of that nature, so you can put it in a specific geographic area with all that GIS data as part of it. They have knowingly said that GeoMesa will never be a part of core MESA because GIS extensions in general require a ton of overhead. Shaping files and all sorts of, or shape files and all sorts of other stuff. And so they say, well, we'll always keep that separate, but we want to make sure they're compatible so people have the GIS extension, right? And then, so you have extensions to core MESA, and then there's kind of like building blocks. And so I'm going to focus on the ones that I built just because I know those the best, so I can kind of dive deeper into those. But there's also like the building blocks where you say, well, we got core MESA, what are those behaviors that can be available for other people to install with core MESA that are compatible, all right? And so you got extensions to core MESA that really kind of mess with the underlying how agents are sequenced and how the landscape works, all right? And then building blocks that are just compatible with MESA that you can install in addition to it. And I would contend that underneath this, the larger question of this is that what are the dynamics of abstraction and encapsulation, or what are the rules in place to say, hey, if you're going to build or what rules need to be put in place, if you're going to build a building block for MESA, you should really follow these best practices to make sure it stays compatible, right? And then it reduces the overhead of the user to incorporate that module into a core MESA setup, right? So, and this isn't necessarily new, right? Like networks, computer networks, deal with encapsulation. You get, it's called the 4-layer model. And they try and keep those separate, so that way, and you keep them, their dynamics encapsulated, so that way they're very compatible between each setup that's created, right? So these aren't necessarily new ideas, but they haven't necessarily been figured out for an agent-based model type framework, right? So this is kind of where we're at. All right, so the purpose is to develop this repository of algorithms. I'm not sure exactly what it looks like or where it's going to go, but it's gotten started. So on the left here is just a screenshot of MESA's documentation, right? And one of their documentations is just a run through of how to set up your own MESA package, right? Here's some basic coding principles, all right? And then this is what we believe the benefits are. And I would contend just to kind of discuss this a little bit deeper. If we have these building blocks that can be removed and applied to other problem sets, then I would this will help at least mitigate in some senses the reproducibility crisis, where somebody could say, hey, I applied this building block to this problem. Somebody else could come in and apply it to, different people can apply it to different problems. And then those really useful and well thought out building blocks will kind of be proven over time as people say, hey, this is really good for what I'm trying to do. This is a critical building block. Let me put it in my own code, right? And then on the right is just another screenshot of what MESA packages is right now. It's just on Project MESA's wiki page, right? So it's very, very low maintenance. All right, and then here's a couple of them. So you have MESA Geo, which I talked about. You have the Econ's Agent Resource Toolkit. So that's being developed, I believe, out of Johns Hopkins. And really, this is kind of a bad on me, but there's a bunch of tools within inside that we're trying to figure out what's the best way to point directly to those tools if you're looking to apply some type of economic algorithm against your agent-based model. And then we have these two, which are built out, and we'll discuss in more detail just to give some more conceptualizations of this idea, some more examples. All right. So as an example of like kind of get into the nuts and bolts of a building block, and then what I think right now matters for how that building block should talk to core MESA in this case. So this is an example. This algorithm is called the bilateral Shapley value. Real briefly, it's an algorithm. It's actually proven pretty robust, and it's been used in everything from trying to determine where to put a high voltage transmission line in Southern California, and I used it in a problem of looking at the coalition of Libyan tribes during their civil war, so it just looks at how, based off two parameters. Affinity, which you can look at as kind of like ideological closeness, and power, which you can measure in any number of ways, right? Like based off those two parameters, how likely are two people or two groups going to come together in a coalition, all right? And for that, so then this kind of becomes the key part of what's that connective tissue look like between these building blocks, right, and the core framework, right? In this case, it takes, it's a fairly simple algorithm, right? It's one algorithm about coalition. Some people have put this together with other building blocks where you have the bilateral Shapley value. So how do the coalitions form? And then conflict onset theory. I'd say, so once these coalitions have formed, what dynamics might cause them to go into conflict? And I think underneath that, they also had and this is actually done in NetLogo, some code that looked at harvest for that week to look at tensions that are going to occur between this coalition and then when they're going to go to conflict was the idea of that model, right? So that's the idea of kind of building blocks that you can put together with different agent-based populations and different data, right? But in this case, it's really you could run this inside your agent-based model each step or each couple of steps because it does depend on how big your agent population is. Does have some computational complexity to it, right? But you can just throw this right in there, and it seems to be compatible pretty easily with any agent-based model in MESA, right? All it does is take MESA's agents, the list of agents that you instantiated, all right, and effectively give it a new list of agents that are based off that coalition, right? It requires one line, low overhead. So that was the idea to try and keep it as an efficient building block, which, as I kind of said earlier, was not. The model was first built, and then it took some effort to really pull out just that algorithm and make it efficient and compatible with MESA. All right. Another kind of more complex one that goes on the border between an extension like a GeoMesa or actually a building block is this one, which is multi-level MESA. So this kind of just speaks to the question of, well, how can you have hierarchies like scales or layers or levels is a terminology I picked after extensive literature review, but how can you have levels of agents, right? So that's how can you have a family, a neighborhood, a town, and then a city, right? And potentially have all those different layers working together. Or if you take like an organization, you have just to familiar with the military stuff, you have your platoon, right, as one group, a company, a battalion, right? And each of those are kind of their own group within that, and there's interaction, but they're also made up of smaller and smaller pieces. So how can you capture that? All right, and so that's what multi-level MESA attempts to do, where you can have, your single agent as a person, all right, but also have layers of organizations on top of them and interactions between each of those layers. All right. Again, I'm working with a person out of the University of Bonn right now to see if we can integrate this into his model I'll go into details about that, into a model that he has. Right, but the idea is that this is an extension where I could take his MESA model and say, okay, well, with that, we just have to throw this stuff in or throw this other module in on top of it, and now we can extend your model. So in a sense, we're trying like a real time, what are the challenges with this and integrating it already into a MESA model? All right. So we're still kind of learning and figuring out those larger and deeper questions involved in this. All right. So with that, I'll leave it at a prediction, and then I think if time for about 20 minutes, that should be good. But I would contend that how this would play out. So if this effort, whether it's MESA or MESA or whatever framework people prefer, is able to get off the ground, then what will happen is certain algorithms and building blocks will be used a lot. All right. And then there'll be a lot of algorithms or building blocks that are built but are only used a couple of times. So we'll get a heavy tail distribution. All right. And then I think from that, and seeing how that plays out, I think that is where it could potentially get used essentially like a open source exploration to get some more insights into complex systems where it could say, okay, well, these are the ones that keep getting used. Does that provide us insight into potential generative mechanisms for complex systems? All right, or what can we learn from the fact that these types of building blocks seem robust and heavily used, and these ones don't? Does that provide us any insights? So hopefully we can do kind of like a meta-analysis and use that as a jumping point to get some more insights into complex systems. All right. So with that, hopefully it's pretty brief and straightforward, but hopefully it was insightful. So at this point, I'll just open it up to anybody online to see if they have any questions, comments, or concerns.
Thanks, Tom. That was fantastic. Very interesting. I just want to remind folks, if you have questions, just post them in the chat here, just so we're not talking over each other. And Andrew or Elizabeth or I will ask Tom your question. One of the questions that has come up in the chat so far is the longevity of these agent-based modeling frameworks. I mean, there's been lots, right? There's Ascape, there's Swarm, there's Repast, there's Repast HPC, there's Repast Pi, NetLogo, now MESA. Then we've got commercial products like AnyLogic. Right, New Tech bought the rights to Ascape for a while, so that was a commercial product, and then they released it again. Any thoughts on these dynamics? Do you think MESA is going to have more longevity? Sort of, NetLogo seems to be chugging along pretty well. It's been going for 20 years now, more or less. Do you think MESA is going to be able to hit a sweet spot there too, or do you think, are we still trying to figure out what works in this space?
I would say that is not an easy question. I can give you some insights though, which will hopefully be helpful. From my understanding, one of the reasons NetLogo kind of continues is that it has a pretty reliable funding stream. I know for Jackie and David, when they set up MESA, they really set it up using kind of the open source culture, so that there's no one person that kind of owns it entirely. And that even if they, fade away based off life events or whatever, that other people are kind of in the wings to pick it up. With that being said, because I didn't necessarily appreciate it beforehand, if anybody's interested in contributing to MESA, it's literally as easy as to have a developer meeting once a month in the evening that people can sit on. But it is very much an open source community. And it's really, I would say MESA is not there yet, but it's getting there based on how many people are using it, where it becomes self-sustaining. And for Python, or for like the larger Python ecosystem, you can kind of, I guess, a metric for when it reaches that sweet spot is when it becomes its own foundation. So like you have Python, went to a foundation, and now you got some other things like NumPy. And I think Matplotlib is another one. Is like very well used, heavy libraries that have essentially reached a certain threshold that they become their own foundation, and that's where you could say, okay, that one's going to be self-sustaining. I don't know if I would say MESA is not there yet, but that is unequivocally one of the goals of Jackie and David to do. And the more people contribute and use it, the kind of closer it gets towards that goal.
Okay. Another question. There's some excitement about the cooperative games library that you outlined. Are you
the multi-level MESA?
I think it was that the coalition.
Okay, the bilateral Shapley though? Yeah, uh-huh.
That's it. Are you continuing to develop that? Is there going to be other algorithms put into there? Are you going to continue to flesh that out, or is that more or less done?
No, I mean, it's still on my GitHub repository. I'll try to get the link to it there. I still use it occasionally, but this is where the open source is both great and horrible, kind of all at the same time. Where if people, if you fork that library and you have some interest, you're like, hey, I got a bug. I will absolutely go in there and fix it. And then, again, it's kind of like MESA, but at a smaller scale. Like if people start using it, then I'll make sure it's kind of constantly updated. It still works from the last time I used it, and it'll just be if it gets momentum, then it will grow on its own. And again, I'll follow kind of like the MESA model, where I'll make sure I'm not the single point of failure for it as it gets more traction. But so in short, it still works. It's kind of I am the single point of failure right now, but I got no issues with people contributing to it, making it better, or say, hey, I'm having a problem with it. Why don't you fix it? And then I'll go in and fix the code.
Okay, I'm going to put in a shameless plug for the CSSSA's annual meeting right now, and say this might make an interesting special interest group for the Thursday morning sessions. Sort of MESA and MESA library development and contributing to it and developing it more and trying to build up a community of folks that are actively working on this. Okay. We've been trying to use MESA on some of our projects, and there are some nuances to it that we wouldn't mind correcting, or at least
absolutely,
making it sort of give folks a few more options.
Okay,
especially with regard to the scheduler.
Yeah, absolutely. And I'll talk to I won't belabor this, but I'll write you offline, and then we coordinate. I'll bring in Jackie and David and see if we can set something like that up.
That would be fantastic. Yeah, please do. So one of the things that we discussed a little bit right before we got going was the interest, which I totally support and actively try to further as well, of making agent-based modeling more accessible, easier, faster, cheaper, all that jazz. But like with every other analytic system out there, the easier it is to use, the easier it is to abuse. And as the models get to be more more well-known or more standardized, I think there can be that can help to mitigate. I mean, everyone understands, gross generalization, everyone understands what a t-test is and sort of the underlying assumptions that underlie it. And so if you see a t-test come up, you can say, well, is your data normal? How normal? And have a sense of whether or not it was appropriately used and that sort of thing. Is that sort of the motivation here, that you're trying to figure out, ways of not only making it more accessible for folks and easier for a broader community to leverage, but by doing so with standardized libraries that are well understood, well documented, well tested, so that it'll be harder to screw it up? Or is that or do you see that as being a secondary problem?
No, I would say that's absolutely one of the benefits of this. I did not necessarily, until I went to this PhD, and I appreciate the benefits of open source, where it's just applying a algorithm against a ton of problems that like one person couldn't even anticipate. But I would say that becomes a crucial aspect to it, where if you have well-known, well-respected algorithms that particularly in the policy domain, that gives more confidence in what you're doing. And I mean, not been in positions, but been in organizations that have spent millions to billions of dollars on stuff. I mean, if they can having greater confidence, right? You never get rid of risk, but having greater confidence in what they're looking at and the decisions they're making would be a huge boon. So I would say that is absolutely a crucial aspect of developing, this infrastructure. Because right now it becomes a one-off model. And as an example of Jeffrey Epstein's model on civil violence, right? Yuri Walensky went right and coded it out and realized he had an equal sign between like two real numbers and a lot of fractions, so they're never going to be equal. And he's like, hey, you got a problem here, and he fixed that bug, right? And then it fundamentally changed the results of the model, right? That people have been using and citing. So I think having more people apply it becomes a crucial aspect to improving the confidence and rigor of models that are being used for real life decision making.
Yeah, well, and quite honestly, that's one of the things that I find appealing about MESA and just the use of Python is that there are enough resources out there. I mean, these documenting and writing up your results doesn't have to be a static PDF file anymore. It can be a live website where you're running the code, you're seeing the results, you can tweak the parameters, you can tweak the underlying assumptions and see what kind of impact that has on the results in real time, which I think is very exciting, especially within our field of computational social science, where the assumptions can matter.
Yeah, absolutely. Yeah.
Let's see. Let me just take a look at some of the questions that are coming in. So let's see. Here's a question about some of these building blocks. Our group is working on social primitives, which has pushed us to understand very fundamental processes, such as how agents update sequentially, simultaneously, etc., and how that affects model evolution. How basic do you imagine the building blocks will end up being?
I guess my short answer to that is I would assess they will cover the range. There was I can't remember his name, but there was one dissertation that came out of George Mason that found out, like the sequencing of agents really does matter. So I think just kind of like physics, where we got people looking at this fundamental, what is going on between quantum and the classical stuff. You have that thing, but at the same time, you have other folks working at what's a practical application we can use to researching solid state physics or whatever. So I think it will, or even like computer science, it'll become different pathways or niches within the larger effort, right? And then potentially, foundational changes to the framework and foundational research will have a rippling effect all the way up to, like the bilateral Shapley value or some economic algorithm that somebody wrote. And I don't think that's not necessarily the ideal solution, but I don't think there's any way around it. I think it'll be, you'll have a taxonomy of different efforts based off what people's research interests are.
Yep, that was Ken Comer's dissertation, wasn't it?
Yeah, Ken Comer, that's right, yes.
Yeah. Yep. I absolutely agree with you. There's sort of the computer science side of how one builds and executes an agent-based model. Then there's the social science side about how the agents should work and interact with each other and come to decisions and things like that. And yeah, I absolutely agree. Also, I mean, there's no reason to think you absolutely have to pick one or the other. And it's one of those things where it would also be nice to see a standardized testing sort of suite or something like that coming up where it's, okay, here's our model. It's based on these social science theories. We've implemented them in this way using these libraries. And now the execution side, we're testing, buffered, unbuffered, sequential, randomized, probabilistic, you name it, for the agent activation. And we're finding that our results are very sensitive or robust to that kind of thing. and all that jazz. So yeah, absolutely. Or even you could imagine using something like one of Miller's ants algorithm to just try to find ways of breaking your model. Where is it sensitive?
Yeah,
and that should just be a standard procedure in how these things are developed, documented, written up, how the results are caveated, all that.
Yeah, absolutely. Yeah, it's like Railsback and Grimm, right? They'll work on OOD and pattern-oriented modeling. But yeah, absolutely. Fundamentally agree with everything you're saying.
Yeah, testing these things, because like you said at the beginning, these things are very sensitive, and it's really hard to put them together correctly. Yeah. There are a lot of moving pieces, and these decisions can have a big impact.
Yes.
I mean, just knowing how many agents to have in your model is non-trivial. I mean, ideally, it's maybe 1-to-1 with the system you're interested in, but that's not practical sometimes. So then how many do you need? We scaled the civil violence model up by several orders of magnitude, and at the aggregate, all the dynamics flattened out. There was no burstiness. But what's interesting, if you look at the micro scale, you still got burstiness because there are these propagating waves of rebellion and then getting imprisoned and things like that. So yeah, it's fascinating. On the whole, there is a single, sort of a constant level of rebellion in the system. But then on the micro scale, it was these propagating waves going across. So you still ended up with the bursty dynamics at any sort of individual point. And so it's a non-trivial question. Let's see, there another question just came in. 1 second. Okay, yeah. So this is another really great point. And coming at this from the DoD, I mean, I assume, keenly aware of VV&A, verification, validation, and accreditation. And for those of you who aren't familiar with that, verification, did you build the model correctly? Validation, did you build the right model? The right model. And accreditation is essentially, should we trust the model in this context when we're making this kind of decision? And the DoD has a very rich history in how to go through this. But for better or worse, it's largely physics based. It's about, are we modeling the parabolic flight of this projectile correctly? You can go out in the field and see if you aren't, and then typically add more detail, which, as we're all aware, doesn't necessarily work in the social science arena. And this comment here, I think, is particularly apropos. There's another aspect to all this, and that's how you're going to use the model. Essentially, the accreditation step here. Is it as a thought experiment to just get your arms around sort of what are the major moving parts here? Or are you actually trying to reproduce the thing and try to do some fine-grained forecasting for what the system may do over time? And, I think, that's where your libraries can come in, and the idea of standardizing these things can be so important, where you might want to be prototyping things, and it doesn't really matter how you throw it together. You're trying to get a sense of what the system, is sensitive to. But then when you want to get into the nitty gritty, that's where having a set of libraries that are well documented, have been beaten on by hundreds of people and thousands of models, could really help. And again, it's all based on what you're trying to do. And I mean, I'm assuming you've had something similar in your experiences.
Yeah, so I guess the way I kind of say the same thing is that the real benefit is, everybody, I would say everybody, there's particular people that haven't necessarily dealt with like the underlying stuff of even like machine learning or agent-based models. There's this false kind of confidence in what it can and can't do, where they immediately kind of exaggerate it. Well, when I talk about this and how to use models, I say, look, the real benefit of these is helping understanding. So if we can build these libraries, it's not necessarily for that, to make the great model for that senior decision maker. It's really for that analyst and that planner, because just where they're at right now, in particular, is that this will make that, that individual, that person on the line, if you will, much more rigorous, and help them think through their process using computation that, no human is physically capable of doing. So I say that, my focus isn't like, hey, I give you the model that will help you, come up with the right policy. It's to say what I'm really trying to do is give your staff, right, for my case, a new tool that will make them, exponentially better than they were yesterday. Right. And I'm not going to tell you that the models they're building are going to be right. What I'm going to tell you is that it will force them to think through their problems in a much more deliberate way and allow them to understand dynamics that they no human is fundamentally capable of. And then ideally over time as this develops, so we get to like more and more accuracy, or you say like, okay, we got our virtual laboratory, we're seeing what's happening in the real world. It is validated. They are matching up. All right, so now we have confidence that we should try a policy. So in the end, it's we're not necessarily going to solve the problems, but we are going to be better than we were yesterday.
And I think, that's a key component, at least in my experience, when it comes to trying to introduce this tool in a new area. We're not trying to displace anything. This is another tool. It has its place. It's not going to work in all cases. It's not going to be necessary in all cases. But when you need it, it's really nice to have. Yeah, I think you're absolutely right. There's another comment here about essentially where the policymaker fits, and do they want to see the high level aggregate essentially measure, or are they curious? Are they more interested in what's going on, the churn in the middle? Honestly, I like Rob's example here that he's been using the past few years with the unemployment rate. If you're just worried about the national sort of unemployment rate of say 3%, it's pretty static, doesn't change a lot, and it sounds great. But if you're an agency that deals with unemployment claims, or if you're the IRS with W-2s and W-4s and things like that, saying 3% unemployment, that means we should be pretty good, there shouldn't be a whole lot of activity going on. But it turns out that there's still roughly 10 million people every month changing their status within the employment market, changing jobs, losing a job, getting a job. And so there's incredible churn underneath that aggregate measure that a 3% unemployment rate gives you no sense of. And that's really important. And that's where I think, as you were saying earlier, these agent-based models can have so much utility because you can move across these scales and make meaningful statements about them.
Yeah, absolutely. And that's, for my take, right, in the military, it's that same thing, right? Have like aggregate combat statistics, but underneath it, it really matters if you're the one that, is getting shot at or not.
Right? Absolutely.
So.
And that's that's actually an interesting point. Another thing that we've dealt with when trying to put these into more of a policy and decision-making space, especially within the DoD, where the decision-making happens at a very specific rate. So it was the Marine Corps planning process. And then this huge Marine leaned over to me and said, "We pronounce it McPee, and we don't laugh." Like, oh, okay, I wouldn't dream of it. I think you could punch my head right off. It was a 3-day cycle, and it had to be a 3-day cycle. And so the thing was, if you jokers are going to use an agent-based model in here, it's going to be a 3-day cycle, whether you like it or not. And so with a little bit of prep work, we were able to make it fit. They would give us their ConOps in the late afternoon, and we would spend all night coding them up, running them on a supercomputer. And then at 7 a.m. the next morning, we would brief out the results, and then they would go back into their next cycle of planning. And after 3 days, they had their 3 recommendations to give to the commander.
Oh, very nice.
But it was non-trivial.
Yeah.
But the fun part was, because it was a simulation, we could do things that, they have, the red team and the blue team and all that. But we were able to take both ConOps, run them against each other, and then also vary the weather conditions and things like that, and show that, under good weather, Blues ConOp won every time. In bad weather, they got their butt kicked.
Oh, interesting.
Yeah, and it was stuff they'd never been able to do before. So it's worth the effort, I think.
Yeah.
And just a reminder to folks, we do have a few more minutes left, and if you have questions, please put them into the chat. So where are you headed next? What's the next step in all this? This is fascinating and
Yeah,
quite an effort.
Yeah. So, well, this is all kind of new. I'm not sure if it's going to work, but the NIU, so the National Intelligence University, allowed me to stand up a center. I won't go through the name with you. It would take the rest of the time. It's kind of throwing some stones internal to DoD. So I don't think for most of these people don't care about that. But so stood up a center. It really kind of announced it sort of yesterday. It's like a soft opening, they called it, that allows me to, students coming in for the master's degree to focus research on this. We're trying to work with some policy folks as part of the Fragile States Initiative to now like start applying this in the decision making arena with this idea as the backdrop. So if I can get the U.S. government, because this is more interagency than DoD specific, to start integrating agent-based models into what's called the Fragile States Initiative. But then from the iteration on that, we can start to ideally pull out these building blocks and allow those to be used by other, State Department and USAID folks to try and implement this. So I will say, that there's a high probability this is like literally just getting off the ground. I don't know if I'm in sand or on rocks right now, so it could gain literally zero traction over the next couple of weeks and kind of fall on its face. Or it could get some traction, and then we'll see what happens. But regardless, I'm still going to work with the MESA folks and try and figure out what this environment should look like. Can we get this stood up? Can we get some more building blocks? So in my day job, I'm trying to do this as like one of my main efforts, if you will. But in reality, even if that doesn't work, I'm still going to hammer away at this because I believe in it. So anybody that has a building block, I can help you package it up and turn it into turn it into a Python package index. If you want to use something like the bilateral Shapley value, you find some issues with it or run into problems, just let me know. But in this case, I take the more like open source community. If we all work together, we'll all be better off. So it's I guess right now I'm trying to get it official, so to speak, as part of my day-to-day grind. But in the end, I'll still do it as a side job if that's what it takes.
So, are you teaching agent-based modeling?
No. So, well, I integrate it into the classes. So I teach in the data science department. I integrate it into the classes at various levels. And some people, or a couple of students, are attempting to do agent-based models as part of their research stuff. Kind of going back to reducing obstacles. And again, this is my personal opinion, does not reflect the views of the U.S. government or Department of Defense. Is that our big push right now is honestly to get more folks just computationally literate, where they can program. And we focus on Python because it's better than R for agent-based models. But it's also a pretty easy language to learn, and then they can apply it to other things like the machine learning and the deep learning stuff. So we're really right now just trying to get more, I'd say, technical capability in our attempt up there, and ideally that will give us like the baseline. So as these folks move out to whatever it is that they do after they graduate, then once the infrastructure gets set up, they have the kit bag to, it's like, okay, I've seen that now. And now I'm starting to see better tools and I know how to use them and employ them. So we'll see how that works. But as I said, that's one of the big arguments I make inside the U.S. government is like, hey, really, I contend, again, personal opinion, that, and I say this as a former history major, right? I don't come from a computer engineering background, that the literacy of the 21st century is high level coding like a Python R&R. That's the Excel of today. And if we want to remain competitive in like the world economics and stuff, we're going to need more people that have those tools. So it's not like, hey, now we got reading, writing, arithmetic. That's like reading, writing, arithmetic, and coding. I would contend that our technologies reached that point. But that's one opinion among many. So
I share your opinion.
Yeah.
We've got a question about the fragile states. Let's see, on fragile states, do you do evaluations of what state a system is in? E.g., how close to criticality is a given system and at what scale is it being evaluated? You see ABMs as a means to evaluate the state of a system, or are there other tools you use?
So I will say we are not there yet. Like right now, it's just saying there's this initiative. We think that this agent-based models as a tool can help with it. So I probably hopefully in 18 months, I will be able to provide you with some more. It won't be an answer, but some more kind of thoughts on that based off that question. But right now, it's a lot of trying to convince larger organization like, hey, we think this tool is useful. There's a lot of people potentially looking at it. What do you think? That is literally the stage we're at right now.